Good afternoon, everyone. Welcome to the third tutorial of this tutorial session. So in this tutorial, I'll be solving assignment 3 from last year's course. And if you guys have any confusion regarding the lecture videos uh, or any or if you have any confusions regarding the assignments, regarding the past assignments, you can unmute and ask, or you can write in the comment section. Okay, I'm sharing the screen. I have shared the screen. I hope it is visible to everyone. If not, then please tell me. Okay, so the first problem is we are given a function with two variables. So f of x, y equals to ln of 2x plus 3y. And we're asked to show that both the partial derivatives are equal. That is, f of xy equals to f of yx. So f of xy means del x of del f del y, and f of yx is so it's very easy. We just have to calculate the derivatives. So first, let's calculate del f del x, which is del x of ln 2x plus 3y. So now this, it is partial derivative with respect to x. So we need to treat y as a constant quantity here. So it will be then 1 by 2x plus 3y, and is del x of again this quantity 2x plus 3y, which is, so this quantity is 2. So we will get 2 by 2x plus 3y. So then the del 2f del y del x, which is basically del y of del f del x, it will be del y of 2 by 2x plus 3y. So it's a partial derivative with respect to y. And so there will be minus sign. So simple derivative of 1 by x with respect to x. There will be minus sign. Square in the denominator plus 3y. And then del y of this thing, which will be, so this quantity will be 3, because we are treating x constant while doing partial derivative with respect to y. So then the value will be minus 6 by 2x plus 3y whole square. So this is del 2f del y del x. Similarly, we have to calculate del 2f del x del y, and we have to show that these two are equal. Then let's calculate del f del y, which will be del y of ln 2x plus 3y, which is 1 by 2x plus 3y and del y of 2x plus 3y, and this quantity is 3. So it will be 3 by x plus 3y. And if you calculate del 2f del x del y, which basically means del x of del y, so it will be del x of x plus 3y, which equals to 3 is a constant, minus sign, square in the denominator, 2x plus 3y whole square, and then del x of this quantity, 2x plus 3y. So del x of 2x plus 3y it will be 2. 6 by x plus 3 square. So this is same as del 2f del y del x. So del 2f del y del x equals to del 2f del x. So the given relation, it is true. Now the next problem is, if you have any confusion regarding the solutions, you can just unmute and ask, or write in the comment section. So the next problem is, we're again given a, so f of xy is a function of two variables x and y, and we are asked to find del 3x by del y del 2x. So which is basically del y of del x of del f del x. So first we need to calculate del f del x, then we need to calculate del x of that, and then we need to calculate del y of that. So it's again very straightforward. So del x of f of xy, which is del x of e to the power xy. So now e to the power xy, so it will, it's derivative to the power xy, and then del x of xy. So now, as it's a partial derivative, treat y as constant, so it will be y times this derivative will be only y, so y times e to the power xy. So now we need to calculate del x of that. So this del 2x del 2f del x2 is del x of del f del x equals to del x of y e to the power xy, which equals to, so we'll treat y as a constant, so the third side the derivative of the power xy is the power xy, and then again del x of xy. This term is as before, that is y, so y square e to the power xy. So now we have to calculate del y of that, del 2x del 2 of del x2, del y of del 2f del x2 will be del y of y square e to the power xy, equals to, so del y, so first we have to calculate the derivative of y square with respect to y. So it will be 2y to the power xy, then plus y square next to the derivative of xy, that is the power xy times del y of xy. This will be del y of xy, so we will keep x constant, so it will be just x. This del y of y is 1. So it will be 2y to the power xy plus xy square to the power xy. 2y plus xy square to the power xy. So the first option is the correct one. 2y to the power xy plus xy square to the power xy. Now the next problem is, so you are given x cube minus 2y square plus xy equals to 0. This is a function of f of xy equals to 0. And so here you cannot directly express y as, as a function of x. So you cannot directly do the derivative. So to get the derivative, what we need to do is we need to use the implicit function theorem, which is dy dx equals to minus of del f del x del f del y, provided del f del y not equals to 0. Okay, so here our f of xy is x cube minus 2y square plus xy. So first we need to calculate del f del y, and we are asked to find out dy dx at point 1 1. So del f del y equals to, we treat x as a constant, then it will be minus 4y plus x. Now del f del y at point 1 1, it will be minus 4 plus 1, which is minus 3, and del f del x, so del f del x will be del x of this, so we will treat y as a constant in that case, so it will be 3x square, derivative of this term is 0, and derivative of this term will be y only, so it will be 3x square plus y. So del f del x at point 1 1, it will be, so 3 plus 1 is 4. So you can see that del f del y is not equals to 0. So this dy dx we can uniquely define, and its value will be dy dx at point 1 1 equals to minus of del f del x at point 1 1 by del f del y at 1 1, which is 4, minus sign here, and del f del y is minus 3 at point 1 1, minus 3. Then dy dx by 1 1 equals to 4 by 3. This is the correct option. Okay, next problem is very similar to the previous one. So we were again given a function of xy, so we're calling it f of xy, which is x square plus xy plus y square minus 7, and it equals to 0. And we have to find out dy dx at point 1, 2. So again, we cannot write y as a function of x directly. We will use implicit function theorem, that is dy dx minus of del x del y. So f of xy is y square plus xy, sorry, x square plus xy plus y square, 7. So we first calculate del f del y. Del f del y equals to treat x as a constant, then it will be derivative of first term is 0, derivative of second term is x only, derivative of third term it is 2y, and the last derivative last one is 0. So del f del y, we have to find out dy dx at 1, 2. So then del f del y at 1, 2, it will be x equals to 1 plus 2 times 2, 4 plus 1, that is 5, and del f del x. So del f del y at point 1, 2 is not 0, so we can find dy dx at this point. Del f del x, so derivative of first term with respect to x is 2x, the second term is y, and the rest is 0. It's 2x plus y, and del f del x at point 1, 2 is 2 plus y equals to 2, so it is 4. So dy dx at point 1, 2 is to minus of del x at point 1, 2 by del f del y point 1, 2, which is del f del x is 4, del f del y is 5. It's 4 minus of 4 by 5. So the correct answer is the first one, minus of 4 by 5. Now the next problem is, we are given a function, this is f of xy equals to x y square, and we have to find out the gradient at this point 2 minus 1. So the gradient of f of xy equals to del f del x I hat plus del f del y j hat. So we basically need to find out del f del x and del f del y. So del f del x is del x of f is xy square, which is just y square, and del f del y equals to del y of xy square, which is, so we treat x as a constant, so derivative of del y of y square, x times derivative del y of y square, that is 2y y. So, okay, so gradient of f is y square I hat plus twice x y j hat. And we have to find out this gradient at point 2 minus 1. So gradient of f point 2 minus 1 equals to, this is minus 1 square I hat plus 2 times 2 times minus 1 j hat. So it will be I cap plus, so there is minus sign on, so it will be minus 4 j cap. So I cap minus 4 j cap. Second option is the correct one. So now the next problem is, again it's a, we are given a function which is a function of x, y and z. It is x square plus y square minus 2z square. And again we are asked to find out the gradient of this function f at point 1, 1, 1. So the gradient of f is, the gradient of f is del f del x I hat plus del f del y j cap plus del f del z cap. So gradient of, so gradient of f at point 1, 1, 1, we're asked to find out it at point 1, 1, 1. So it will be del f del x at point 1, 1, 1 I hat plus del f del y at point 1, 1, 1 j hat plus del f del z at point 1, 1, 1 k cap. So del f del x, f is x square plus y square minus 2z square. So del f del x is 2x square. In that case, del f del x at point 1, 1, 1 will be 2. Similarly, del f del y is, sorry, del f del x is 2x. Del f del y is 2y. So del f del y from 1, 1, 1 will be again 2, and del f del z is, we take so as constant, so derivative of only this minus 2z square, that is minus 4z. So del f del z at point 1, 1, 1 will be 2z equals to 1, so that is minus 4. So the gradient at point 1, 1, 1, it will be then gradient of f at point 1, 1, 1 will be then del f del x at point 1, 1, 1 is 2. It's 2 I cap plus del f del y at point 1, 1 is again 2. 2 j cap, and then del f del z at point 1, 1 is minus 4, so it is minus 4. This is the value of grad f at point 1, 1, 1. The last one is the correct one. It's the correct option. In the next problem, we are asked to find out the directional derivative of this function f of xyz, which is xy plus yz plus zx at point 1, minus 1, 2, and the directional derivative at the direction of this vector. So let's call it the d vector. So the d vector is 3 I cap plus 6 j cap minus 2 k cap. Okay. So the directional derivative will be, So first of all, we have to find out the grad of f to find out the differential derivative. So grad of f will be del x of f I hat plus del y of f j cap plus del f of j cap. This will be, so to del x of f, so del x of f, it will be y, del x of this term is 0 and this term is z. So y plus z. Similarly, del f of y, this will be x. So the del y of first term is x, second term is z, so x plus z, and the third term is 0. And the plus del f of z, it will be, so the first term of del z of first term is 0, the second term is y, the third term is x. So it will be y plus z I cap plus x plus z j cap plus y plus x k cap. So now we have to find out the initial derivative at this point. So then the grad of f at this point is at point 1 minus 1 2, 1 minus 1 2, which is so if you put the values, then y is minus 1 plus z is 2 I hat plus x is 1 plus z is 2 j hat plus y is minus 1 plus x is 1. Okay. So it will be minus I cap plus 3 j cap and plus 0. So this is the gradient of f at this point 1 minus 1 2. So what does it mean? It means, so basically this is a, for each values of f, this will give you a plane. Okay, so it's a function of x y z equals to some constant. So that is basically equation of a plane, equation of a surface in 3D. So now what does it gradient operator gives? So for example, let's say this is a surface for a particular value of this f. So now if we change x y z, this grad of f at this point, let's say this is the point of, this is the point 1 minus 1 2. So it will give the depending on the change of x y z, it will give the, if we change the x y z, it will give what is the perpendicular direction. I mean, at this point it gives a normal direction to this surface for a constant f. So if f equals to constant, then it will give the normal direction. So now the directional derivative, it means, it means the component of this gradient of f along this direction, in whatever direction we are asked to calculate the directional derivative. So basically we have to calculate the component of this vector along the direction of d, which is 3 I cap plus 6 j cap minus 2 k cap. 3 I cap plus 6 j cap minus 2 k cap. So which is, This is the vector, and if you want to project it along this direction, what we have to do is you have to multiply it with the unit vector, with the dot product it with the unit vector along this direction. The unit vector along this direction is d vector by mod d. Okay, so now the gradient of f is minus I cap plus 3 j cap. So it is minus I cap plus 3 j cap dot the unit vector of along this direction, that is d vector by mod of d, which is 3 I cap plus 6 j cap minus 2 k cap divided by 9 plus 3 square plus 6 square is 36. 6 square is 36 plus minus 2 square is 4. So it's minus I cap plus 3 j cap dot, okay, plus 6 j cap minus 2 k cap by 36 plus 4 is 40 plus 9 is 49 and root of that is 7. And if you do the dot product, then it will be, so in the numerator it will be minus 3, and so if you multiply the j components it will be plus 18, and then there is no k component, so it will be just minus 3 plus 18. So it will be 15 by 7. Oh, there is no answer. No such answer. Okay, somewhere I have made a mistake. So the grad of f is yz plus I hat. This is fine. This is xz. This del f del z is y plus. Okay, then somewhere I made some mistake. Yeah, okay. Yeah, yeah. Thanks. So this is minus 1 plus 2 is 1. So this is plus. This is plus. So it will be 3 plus 18 is 21. So it is 3. Okay, thanks. So the correct option is 3. In the next problem, we are asked to find out the direction in which the function increase most rapidly at point 411. So the function is f of x y z, which is x by y minus yz. So to check the increase of the function in the direction where the function is increasing, as we are changing x y z, we have to find out the gradient of f. Gradient of f. So we'll say, which is del f del x a cap plus del f del y j cap plus del f del z a cap. So now del f del x is 1 by y, del f del y is minus 3x constant, so it will be minus x by y square. So minus x by y square minus z, and del f del z is minus y. Okay. So then del f del x at point 411, it will be 1. Del f del y at point 411, it will be x is 4, so it is minus 4 minus 1 is 5, and del f del z at point 1 sorry 411 is minus 1. So the grad of f will be x y, grad of f at point 411 will be, so del f del x I cap, that is I cap, then del f del y is minus 5, so minus 5 j cap, del f del x is minus 1, so minus j cap. So we have to find out the direction in which this function increases most rapidly. So the idea is basically, if you want to find out the direction, if you want to find out the increase of this function at some direction, we have to do the directional derivative. So for example, at any direction, for example t cap, if you want to find out the rate of change of this function, we need to do rate of it. So now, at which direction the rate will be maximum? Where this quantity is maximum, this is basically the rate of change of this function at this direction. So now this is basically a dot product. Now at what direction the dot product will be maximum? This will be along the direction of the vector. So the direction at which the function increases the most, it will be the direction of this grad of f. So the direction at which the directional derivative will be maximum, that is basically the direction of this grad of f, which is, so this is the direction of what should I say, maximum or most, maximum increase of f, which is basically grad of f divided by mod of, this is the unit vector along the direction of this grad. So grad of f is I hat minus 5 j hat minus k hat, its mod will be root under 1 plus 25 plus 1 is root under 27. 27 means 9 times 3, so it is 3 root 3. 3 root 3 I cap minus 5 j cap minus k cap. This is the direction along which the function increases most rapidly. So which one is the correct one? It's divided by 3 root 3 to 3 root 3 I cap minus 5 by 3 root 3 j cap minus 1 by 3 root 3. So this will be the third one. Third one is the correct option. Now in the next problem, we're asked to find out the number of critical points of this function f of xy, which is 4, plus x cube plus y cube minus 3xy. So for critical points, the del f del x will be 0 and del f del y will be 0. So to calculate del f del x will be del x of 4 plus x cube plus y cube plus minus 3xy 0. Now this will be first term will be 0 plus 3x square divided by x cube with respect to x. Divided by y cube with respect to x is 0. It's partial derivative, and then the last term is minus 3y equals to 0, which gives basically y equals to x square. And now from the second relation, del f by y equals to 0. So it will be del y of this function. So the first term is 0. Then the second term del y of x cube is again 0. And del y of y cube is 3y square. And del y of minus 3xy is minus 3x equals to 0. Which means x equals to y square. So we need to find all the points, all the so here as we're talking about the critical points, so we will be only talking about the in the real 3D 3 dimension what will be the points. So in that case we, we'll be finding all the points which are satisfying these two relations. So from these relations we can write, so if you put x equals to y square here, so it will be y equals to y cube, sorry, y equals to y to the power 4. X is y square, so y square of, so then it will be y minus y to the power 4 equals to 0, and it was y minus, so this 1 minus y cube is 0. So the two real solutions will be y equals to 0 and 1. There are still two imaginary solutions, but we are not bothered about. So for y equals to 0, so we put here, so when y equals to 0, in that case x equals to 0, because x is y square, and when y equals to 1, x is also 1. So the points are 0 0 and 1 1. These are the two critical points. So there are two critical points in this function. Now the last problem is, we are given a function f of xy, which is x times e to the power y, and we are asked to find out the quadratic approximations of f of xy. So quadratic means we have to do the partial derivative of the second order near the origin, means near the point 0 0. So it will be f of xy equals to near point 0 0, it will be 0 0 plus, just using the Taylor formula, del f del x at point 0 0 x minus 0. So let me write the formula first. So in the neighborhood of, let's say, x1 y1 will be, if you want to expand in the neighborhood of x1 y1, So it will be f of x1 y1 plus del f del x at point x1 y1 x minus x1 plus del f del y at point x1 y1 y minus y1 plus del 2 f del x2 at point x1 y1 x minus x1 whole square plus del 2f del y2 at point x1 y1 y minus y1 whole square plus, sorry, there is a 1 by 2 factorial, and plus del 2f del y del x at point x1 y1 x minus x1 times y minus y1 plus all the other terms that is in the third order. So that we will not include that in the quadratic expansion. Okay. So now the x1 y1 point is here 0 0. So we need to find out then. So f of 0 0 is, so f of xy is x e to the power y. So f of 0 0 will be 0 then, because f of xy is x e to the power y. So then del f del x at point 0 0 will be, so del f del x of e to the power e to the power y is x times e to the power y is e to the power y. 0 0, this is 1. Del del y at point 0 0, del f del y of f xy, del f del y of this point where f is this x to the power y, it is x to the power y, then 0 0 0. So del 2f del x2 at point 0 0 is, so del 2f del x2 means del x of del f del x, and del f del x is e to the power y, so it is already 0 at all points. So del 2f del y2 equals to del y of this quantity, del f del y, and del f del y is x to the power y, so del y of that will be again x to the power y, point 0 0, 0 0 0 again, with del 2f del y del x, which is del y of del f del x, and del f del x is e to the power y, to the power y, so which to the power y, and at point 0 0 its value is 1. So then the expansion will be f of xy. So f of 0 0 is 0. The first term is 0. First term is 0. Now del f del x at point 0 0 is 1. This is 1. Del f del y at point 0 0 is 0. This term is 0. Then del 2 if del x2 is 0, del 2 f del y2 is also 0. So this term is 0. This term is 0. And last term del 2 f del y del x, this is 1. This is 1. So it will be 1 times x minus 0, that is x, so it will be x, and all the terms will be 0. The last term will be 1 times x minus 0 times y minus 0, that is xy. So it will be x plus xy. This is the quadratic approximation of f of xy at origin. This is the second option. Okay. So you can just expand to the power y up to the second order and just multiply. Basically, to the power y is 1 plus y, and you just multiply with x, so you get the same thing. So these were the 10 problems from last year's assignment 3. So if you have any confusions regarding any of the solutions I just did, or regarding the lectures, you can ask in the comment section, or you can unmute and ask. By the way, if you don't want to use implicit function theorem in this, yeah. So in these kind of problems, if you want to just directly to just, okay, no, you have to use. Okay, I'm sorry, I was thinking something else. Yeah, if you don't want to use implicit function theorem here, then you can do just dx of x square plus xy plus y square minus 7 equals to 0. And it will be 2x plus dx of y plus dy x times dy dx plus 2y times dy dx plus to 0. From here you can just calculate dy dx. Dy dx is minus of 2x plus y by x. I think we'll get the same thing. Minus 4. So you can just directly simply derivative with respect to x and find dy dx here. Okay. Anything else you want to ask? Yes. Yes. Increase most. Okay. Hmm. So basically you can just find it out from this expression. So the directional derivative along this direction of b cap, it will give you the rate of change of this function along that direction. So the maximum value of this value will be maximum if we are doing the directional derivative along the direction of this grad f. Basically, this is the unit vector along the direction of grad f. Now it will be minimum if it is in the opposite direction. So it will be minimum when this there will be a minus sign here, because then this value of this directional derivative along that direction will be the minimum. That's the minimum value. Okay, so anything else? Otherwise, you can leave on by that. Yes. Sorry, I'm not getting. Can you write it in the comment section? Okay, length of a curve. Okay. Yeah. 3 3. So maybe what you are asking is maybe there is a equation of curve is given. So any curve you can write it in terms of some parameter. So maybe you are asked to find out this length of the curve x1, y1, z1, x2, y2, z2. So for that you need to do the line integral. So to do the line integral, just dr mod of dr from this point 1 to point 2. So the line integral, it will be, I mean, maybe in the next week or maybe the next week, that will be the topic. How to find out the length of the curve. Okay, one thing I just forgot to mention. So in the last class, someone was asking about how will be the questions in the examination. Will there be any theoretical questions? So there will be numerical questions, but I mean, there will be MCQ questions, but not all of them will be numerical. There will be some concept-based questions also. But you don't have to write and solve, like prove the theory and all those things. It will be conceptual MCQs. RT is hmm, okay. Root 2T I cap root 2 T J cap 1 minus T square T cap. So 0 0 1 root 2 root 2 0. So you are given a parametric equation of this curve. So for to go from this point to that point, so this is basically at t equals to 0 point, and this is at t equals to 1 point. So if you put t equals to 1, you will get this point here in the R. So then what you need to do is just here. So, so okay. So this is 0 0 1 point, right? So if you put t is the parameter here. So basically, if you change t, you will just move along this curve. So basically, there will be a value of t for which you will reach at this point. So now if you put 0 here, t equals to 0, so then your r is 0 0 1, right? Component of r is 0, r will be 0, y component will be 0, and z component will be 1. So if you put t equals to 1, then you will reach at this point. Then is r is basically root 2, and 0. Okay, and now the infinitesimal length, you will just define it by mod of dr. So what you want to do is just integrate dr from this 0 0 1 to root 2 root 2 0. So around this point. Now you have parameterized the curve with t, the parameter is t. So this dr into dr will be root 2 dt root 2. So there will, if for, from every term there will be dt, so I will put dt outside. So it will be 2 I cap plus root 2 j cap minus 2 t k cap and overall multiplied by dt, right? So then d of r vector, it will be 4 plus 4, sorry, 2 plus 2, 2 plus 2 plus 4 t square dt. So it will be 4, if you take 4 outside, it will be 2 times 1 plus t square dt. So this is, so what does this quantity means? It means, so if you are changing t, you are moving along this curve, and now at some point t, if you are asked to find out the infinitesimal length along this point t, this is the quantity dr, right? And then what you need to do is you need to integrate it from this point to that point. So the length will be integrate dr from t equals to 0. So at t equals to 0 you are at this point, at t equals to 1 you are at this point, equals to 1 equals to t equals to 0 to 1 plus t square dt. So you are basically, you are changing t and you are basically adding all these small components. That's the integration, and you have to integrate this. This line integrals, it will be discussed in next, I mean, maybe next or maybe next to next. Okay. Mm, exactly. I mean, what will be the difficulty level? I don't know. There will be this kind of questions, I guess. Okay, I think if you follow the lecture videos and solve the assignments and those activity questions carefully to understand the concepts, then you can do anything. Anything else? Yeah, I think there is. Okay, so let me stop the presentation. Thank you for joining.